Hello and welcome to this how-to video on how to operate the omic skin inside the SIMCA software. In this video we will target some of the tools that are available under the validation group, the rock plot, descriptive statistics, permutations, CV ANOVA and CV scores. And the reason for zooming in on this group of tools is that if you're operating the analysis wizard in the omic skin, you can create a report, and that report will quote some of the outputs of the tools compiled in this validation group. So let us start with the rock plot. The rock plot is a graphical summary of the performance of a binary classifier, and it will display curves for the two binary classifiers. For each classifier, the rock plot contains a graph, and in the ideal world, that graph for each classifier will have an arcing towards the upper left-hand corner where you combine 100% sensitivity and 100% specificity for the binary classifier in question. A quantitative measure of the capability of the binary classifier is provided by the area under the curve measurement. The closer to 1, the better the classifier. If the area under the curve would be 0.5, that would correspond to the curve for the rock function aligning close to the dashed 1, 1 line, and then you would have a classifier performing on average. Another tool that is part of the validation group is the descriptive statistics. The descriptive statistics function will, for each variable being part of the dataset, report 8 univariate statistical indices of conventional type, plus list the number of observations being part of each class of the two-class comparison setup. Permutations, that is a way to randomly permute the y variables and assess the significance of an OPLS or an OPLSDA model. Typically you would run 100 permutations, but you can increase this number up to 1000 if you want to. The output of the permutation test is a plot called the validate model test, and you will have two sets of points. You will have blue squares representing Q-square values and green dots representing R-square values. So for these 100 random permuted models, we are then comparing the R-square of the real model with the permuted R-squares, and then we're comparing the Q-square of the real model with the permuted Q-squares. Then there are two sets of linear regressions, one run through the green dots and another run through the blue squares, that are summarized in terms of intercept measurements. So the intercept for each regression line is reported here in the header of the plot, and these intercepts are also part of the expanded statistics around every OPLSDA model or OPLS model developed inside the analysis wizard. Another tool that is also summarized in the quality statement of each model developed in the analysis wizard comes from something called CV ANOVA, cross-validation ANOVA. This is based on using the residuals from the cross-validation routine in SIMCA, summarizing them and documenting, reporting them according to the standardized reporting formalism of an ANOVA test. So CV ANOVA is similar in scope to ANOVA. It is just which type of residuals you are using that is different. In conventional ANOVA, you're looking at fitted residuals from the R-square, you can say, and in CV ANOVA we are looking at the predicted residuals coming from the cross-validation routine. And what we are reporting in the analysis wizard summary part is the p-value, and the lower the p-value, the more significant the model in question will be. The last tool that is available under the validation group is the CV scores. It will plot in a conventional two-dimensional scatter plot the cross-validation scores as a complement to the regular score plot. So here we have, for one of the models in this example, the cross-validation scores. We can compare those with the normal score plot, and perhaps if we align them side by side, it will be easier to see. So in the left hand part we have the score, OPLS scores for the model comparing the wild type with the upregulated class, and in the right hand part we have the same setup but score values obtained from the cross-validation procedure. So this is an estimate of the scores when each observation has been left out. We can use a highlight here. So what we are looking for here is differences in the distributions between points in the two plots. For any point that changes its positions considerably between the regular score plot and the cross-validation score plot, you can raise a little warning flag. That means that the OPLS discriminant model is very sensitive to the inclusion or exclusion of this particular observation. It is an influential observation that you should be cautious when you interpret. Conversely, if there then are observations which don't change their position that much, that would then indicate that the OPLS discriminant analysis model is relatively insensitive to whether this observation is part of the model or is excluded in the cross-validation phase. You could say that this is an observation that has a lower leverage on the model. So the whole intent with the cross-validation scores plot and comparing it with the regular score plot is to highlight if there are influential observations in a data set that might have a strong influence on the model interpretation. So now we have walked through these different tools being part of the validation group on the home tab of the omics skin in the SIMCA software, and several of these tools are then also used in the report that is created by the analysis wizard. That was all I wanted to demonstrate in this video. Thank you for watching.